Today's show is a mix of objects inside and outside the solar system.
And also an object that made it from the outside in.
And pretty Aurora may not just be pretty, but may sound neat too. Maybe.
And I get to look back at the mission that got me into spaceflight, SpaceX's COTS Demo 2.
All of this now, right here on the Daily Space. I am your host, Dr. Pamela Gay.
I'm your host, Eric Mattis.
And we're here to put science in your brain. One of the ongoing debates among skywatchers of all kinds has been, do aurorae make noise? For thousands of years, people have reported noises associated with these magnificent sky displays. But like researchers trying to document ghosts, consistent and rock-solid evidence has eluded capture. But maybe that is changing. In the cold north of Finland, Professor Emeritus Unto Lane has been using his retirement years to seek out auroral sounds and define the conditions that make them possible. Aurorae occur when solar particles interact with our atmosphere and transfer their energy to gases in the sky, which get excited and glow. Oxygen can shine red or green, and nitrogen adds highlights of blues and purples. That glowing gas is often tens of miles to over 150 miles up. That can't be what we're hearing. Lane has been looking for an effect more down to Earth and theorized that electrical discharges can occur where a layer of warm air builds up between two cooler layers. Called a temperature inversion layer, these kinds of warm air regions can be found just 70 meters up, which is a distance that you are close enough to hear. Lane recorded audio while measuring geomagnetic data. He found 60 candidate sounds, all linked to changes in the geomagnetic field. According to Lane, using the geomagnetic data, which was measured independently, it's possible to predict when auroral sounds will happen in my recordings with 90% accuracy. End quote. This work, which is presented at the Joint Acoustics Conference in Aalborg, Denmark, suggests that the same kinds of conditions that can be linked to aurora can be linked to these sounds. This means you can have sounds without aurora and aurora without sound, but both activities require our Earth's magnetic field to be fluctuating due to something like solar activity. So, do aurorae make sounds? No. Do the conditions that make aurorae possible also sometimes lead to crackling electrical discharges we can hear? Yes. Are there ghosts? We still have no evidence for that. Where you are in the solar system changes just how much of an effect the sun has on you. For Earth, the sun can cause bright aurorae that can extend down into the mid-latitudes. For comets, the changing distance to the sun is what gives us cometary tails. But if a larger body was moved from the outer solar system to the inner, that distance to the sun has different effects. Scientists trying to understand the composition of the thin, misty atmosphere on Ceres have now discovered that the dwarf planet likely formed in the outer solar system and was moved inward. The early days of planetary formation were turbulent times, with Jupiter and Saturn vying for space, ice giants like Uranus and Neptune getting pushed outward, or even yeeted out of the solar system, and small bodies bouncing around like billiard balls as gravitational forces pulled on them in every direction. In the journal Icarus, a team of researchers explains how they used computer models to work through their theory that Ceres formed further out. Let's start at the beginning. Ceres, as observed by the Dawn mission, turns out to have quite a bit of ammonia in that thin mist, which is caused by the warmth of the sun's light. That mist comes up from below the surface, and it's actually a mix of water and ammonia. And then there are all those ice deposits at the bottom of the craters on Ceres. But asteroid belt bodies don't tend to have any sort of ice. They're dry and dusty. And that's why this team wanted to see if Ceres possibly formed elsewhere. That's where these huge computer models came in. The team started with the assumption that Ceres was a planetesimal in its own right. Those bits of rock and gas and dust thought to be the building blocks of larger bodies. As for the result of the simulations, lead author Rafael Ribeiro de Sousa explains, quote, "Our simulations showed that the giant planet formation stage was highly turbulent, with huge collisions between the precursors of Uranus and Neptune, ejection of planets out of the solar system, and even invasion of the inner region by planets with masses greater than 3 times Earth's mass. In addition, the strong gravitational disturbance scattered objects similar to Ceres everywhere. Some may well have reached the region of the asteroid belt and acquired stable orbits capable of surviving other events." End quote. On top of that discovery, the team simulation also found that there were at least 3,600 Ceres-like objects in the early solar system, out beyond the orbit of Saturn. Statistically, that improved the chances that Ceres was formed further out and pushed inward by all the chaos. But the chemical signatures seal the deal. Ceres is too much like objects formed beyond the frost line to have started off in the asteroid belt. Our sun is something of a busybody star, and it seems responsible for a whole lot of chaos. Right now on Mars, 2 of our favorite missions are suffering under a layer of dust. Both InSight and Ingenuity are solar-powered, and the 1-2 punch of oncoming winter and layers of dust are making their solar panels less efficient, and these missions are likely reaching the ends of their lives. This isn't a first. In 2018, with massive dust storms blocking all views of the red planet's surface, all contact was lost with the solar-powered Opportunity rover. Now, in new research published in the Proceedings of the National Academy of Sciences, we learn that the sun's energy, collected in Mars' desert landscape, can drive these world-enveloping storms. This work is led by Ellen Creasy, who notes, quote, "One of our most interesting findings is that the energy excess, more energy being absorbed than emitted, could be one of the generating mechanisms of Mars dust storms. Understanding how this works on Mars might provide clues about the roles Earth's energy budget takes in the development of severe storms, including hurricanes on our own planet." End quote. This is a reminder that hurricane season is approaching, and we are seeing extremely warm ocean waters. While hurricanes don't yet engulf even entire continents, the same physics that is driving dust storms on Mars is driving more and more powerful hurricanes developing on Earth. Speaking of InSight and Mars dust, we have some bad news. Our favorite lander is losing power, as I said, due to all that dust on its solar panels. And the operations team has not found a way to dislodge it. Science operations are expected to end this summer, and the end of the mission is likely to occur in December. InSight landed on Mars back in 2018 and has been through a lot. There was the heat probe that couldn't go underground because the Martian soil behaved differently than expected. There was dust collecting on the solar panels. There was feedback from winds affecting the seismometer. And through it all, InSight's team worked to keep the science going, using the robotic arm and scoop in ingenious ways. InSight has collected data on more than 1,300 Mars quakes, including the magnitude 5 that occurred earlier this month. With all that information, scientists have mapped the interior of the red planet. And InSight also collected weather and magnetic field data, allowing scientists to study those aspects as well. It has been the little mission that could. While we are saddened to hear that the end of the mission is finally approaching, we will continue to report on all the amazing discoveries scientists continue to make with the data collected. Ad Astra Insight, we salute you. On that cheery note, let's turn away from our world and take a look at rocks from space. Stay tuned. I'm not the best at cook, but I can make some really good oatmeal muffins. Usually there is, unfortunately, always that one place in that one muffin, however, where things just didn't mix right, and a clump of flour or sugar makes it through the baking process to break apart as a gritty surprise. These failed attempts at muffin mixing aren't unique to my baking attempts. In fact, our solar system has at least one unmixed rock that is the remains of just one of the many supernovae that formed the material of our solar system. Named Hypatia and found in the desert of Egypt, this meteor has a pocket of material that is best explained as the raw ingredients from a Type 1a supernova. Lead researcher Jan Kramer explains, quote, "We found a consistent pattern of trace element abundances that is completely different from anything in the solar system, primitive or evolved. Objects in the asteroid belt and meteors don't match this either. So next, we looked outside the solar system." End quote. This work is published in a new paper in the journal Icarus. Kramer further explains, quote, "In a sense, we could say we have caught a supernova 1A explosion in the act, because the gas atoms from the explosion were caught in the surrounding dust cloud, which eventually formed Hypatia's parent body." Let's break that down. A Type 1a supernova is an exploding white dwarf star. They explode with a specific energy and brightness and a well-understood variety of atoms formed in the process. In theory, that material, along with the material from any number of other supernovae, comes together in a whole mix of elements. That material forms a giant molecular cloud mixing with material left over from the formation of the universe. And all this mix of atoms and molecules then eventually forms solar systems like ours, after it gets well mixed. We thought. But just like my KitchenAid can struggle, so too can the universe. And now you know.
As rockets launch more and more, their environmental effects should be taken into account, according to a new study published in the journal Physics of Fluids. Rockets on the whole don't produce as much pollution compared to global aviation, but this will change as more and more of them are launched. The biggest rocket launch providers are SpaceX for their seemingly weekly Starlink launches, but also suborbital tourism providers Blue Origin and Virgin Galactic. The team from the University of Nicosia studied the effects of a simulated rocket plume up to an altitude of 67 kilometers. They found that the combustion product nitrogen oxide was concentrated up to an altitude of 10 kilometers, where the atmosphere can spread it higher and further. The 10-kilometer limit is because of the pressure when the gas leaves the end of the rocket engine's bell. According to the team's fluid dynamics simulation's worst-case scenario, the rocket emits enough nitrogen oxide to make 2 cubic kilometers of atmosphere hazardous to humans. Carbon dioxide is another combustion product, and the team found that the rocket will produce the equivalent of 26 cubic kilometers of CO2 for every 1 kilometer of altitude. The team does not know how long it takes for these different combustion products to disperse into the atmosphere. Above a certain level of rocket launches, the natural level of pollutants will go up. This will make climate change worse. Paper co-author Dimitris Drikakis said, quote, "We hope that the commercial flight companies such as SpaceX, Virgin Galactic, and the New Shepard, and their associated engine manufacturers, will consider these effects in future designs," end quote. And now it's time for This Week in Rocket History. 10 years ago counts as history, right? Stay tuned. This Week in Rocket History is a launch that I've wanted to cover for a long time, the one that got me interested in spaceflight, SpaceX's COTS 2+. Back in the ye old days of 2006, NASA started a program for private companies to launch cargo to the International Space Station. This was necessary because of the pending retirement of the Space Shuttle. NASA thought that cargo delivery to the ISS was a good starting point for future commercial use of low Earth orbit. It would also free NASA to do more important things in deep space. The program started with 6 companies receiving funding from 21 proposals received. These were narrowed down to 2 in 2008, SpaceX and Orbital Sciences. Orbital Sciences is well known for developing the Pegasus, the first commercial orbital rocket, which first flew in 1990. At the time of the contract award, SpaceX had not launched a single Falcon 1 successfully, so NASA was taking a bit of a risk by awarding them the contract. The COTS contract was critical for early SpaceX, according to President Gwynne Shotwell. Quote, "We would not be the company that we are today without the support of NASA." End quote. The COTS program required several demonstration missions before a Dragon could visit the ISS. SpaceX had to prove that the capsule could go to orbit and back safely. It was up to SpaceX and Orbital Sciences to propose, and NASA to approve, what milestones these missions would demonstrate. The rendezvous system, called Dragon Eye, was demonstrated on 2 of the last Space Shuttle missions, STS-127 and 133. The first flight of the Falcon 9 in 2010 carried an instrumented nose cone shaped like a dragon, but no real payload. The second flight of Falcon 9, also in 2010, carried a real Dragon capsule capable of surviving re-entry, but only a partially functional trunk. At the end of the mission, it successfully landed, making SpaceX the first private company to recover something from orbit. The next demonstration would see a Dragon approach very close to the ISS and then berth with the station a day later. The original plan was for rendezvous and berthing to be on separate missions, but SpaceX convinced NASA that combining the objectives was better. Having to build only one capsule and rocket also saved a lot of money, because at this point, neither Falcon 9 or Dragon were reusable. COTS 2 Plus was the last of Dragon's orbital demonstration missions, and would result in SpaceX becoming the first private company to visit the International Space Station. I'm very carefully not saying docking, because Cargo Dragon was not capable of doing this. Instead, it would maneuver to a few meters from the station, where it would be grabbed by the Canada arm controlled by an astronaut and attached to the station. The modified COTS 2 Plus mission launched on the third flight of Falcon 9 on May 22, 2012. I was in middle school. It would spend almost 10 days in space, 6 of those attached to the ISS. During the first 3 days of the mission, SpaceX first demonstrated different systems on Dragon while it was hundreds of kilometers away from the ISS. Later, Dragon flew 2.5 kilometers under the ISS without stopping, while the crew verified they could control Dragon by turning on its strobe light. After this, NASA cleared it to approach for real the next mission day. After several planned holds in its approach, it got closer, and Dragon was finally given permission to approach the capture point 9 meters from the station. Astronaut Donald Pettit grabbed Dragon for the first time and attached it to the station. The approach was tense because the rendezvous system was confused by a reflection on one of the modules, but SpaceX quickly uploaded a fix. Once the spacecraft was attached, the astronauts first needed to ensure it was safe to enter. The station's air is very important, and there are many procedures to follow before opening a capsule's hatch. Once that was done, the station crew unloaded the cargo. After the capsule was unloaded, it spent a few more days at the ISS while astronauts packed it with cargo for return to Earth. NASA observed the spacecraft's re-entry with infrared cameras to gather data. After splashdown, it was taken to the company's testing center in McGregor, Texas for processing. Dragon was officially certified to carry cargo to and from the ISS on August 23, 2012. The COTS 2 Plus capsule is on display at the SpaceX HQ, hanging from the ceiling in front of the employee cafeteria. If you watch a SpaceX launch stream, you can sometimes see it in the background. And now for some statistics. The number of toilets in space is 7, 4 on the ISS, 1 on Soyuz MS-21, 1 on the Crew Dragon Freedom, and 1 on Tianhe. We keep track of orbital launches by launch site, also called spaceport. Here's that breakdown. USA 28, China 15, Russia 4, Kazakhstan 3, New Zealand 3, India 1, Iran 1. From those 56 launches, a total of 1,013 spacecraft were put into orbit. Your random space fact for this week is that the entire core of the moon is off-center slightly and shifted towards the Earth. This has been the Daily Space.
You can find more information on all our stories, including images, at dailyspace.org. As always, we're here thanks to the donations of people like you. If you like our content, please consider joining our Patreon at patreon.com/CosmoQuestX.